First we are going to find the value of a dot I vector dy dx. So here surface integral over 0 to 1 of this a vector 4x I vector minus 2y square j vector plus z square k vector dot I vector dy dz. Okay, so next we have to take the dot product. For the dot product we can have the value for this I vector, that is 4x, because I dot I value is equal to 1. J dot I is 0, K dot I is 0. So we can get integration, that is surface integration over 4x with respect to dy and dz. So first we are going to integrate with respect to z. So here it is 4xz, the limits from 0 to 1, and then we have to get that answer as 4x, correct? Z is equal to 1 means here 4x. Then we have to integrate with respect to y, that is 4xy. With the limits from 0 to 1 we can get 4x. Okay, this is the answer for that surface integration. Since x is equal to 1 in I vector, that is given in the problem, right? It is bounded by cube, that value is equal to 1 in I vector. Then this term becomes 4 into 1 is equal to 4. So surface integral of a dot I vector dy dz is equal to 4. And then in the opposite direction, okay, so in that direction its value is 0. So we can mention that value as 0. Next, consider the j normal component. So here it is surface integral of a dot j vector dx dz is equal to double integral of 4xi minus 2y square j plus z square k vector dot j vector dx dz. So here we are having the value only for this j vector because j dot j is equal to 1. So that is minus 2y squared. Then we are going to integrate with respect to z. This becomes minus 2y squared z with the limit 0 to 1. Okay, substitute the limits here. So z becomes 1. So here we can get integration over 0 to 1 minus 2y squared dx. Then integrate with respect to x. We can get minus 2y squared x from 0 to 1. Substitute this value. We can get minus 2y squared. Okay. As we know that the value of y is equal to 1 in the j direction, we can substitute that value here. So this integration becomes minus 2. That is surface integration of a dot j vector dx dz is equal to minus 2. In the opposite side, its value is 0. So we can say a dot minus j vector dx dz is equal to 0. Similarly, we can obtain the value for this a dot k vector dx dy. Okay, so here the same way we can substitute the value of this a vector here and take the dot product for this k vector. We can get z squared. Then integrate with respect to y, that is z squared y with the limit 0 to 1. Substitute that limit here. So this integration becomes integration of z squared dx, that is equal to z squared into x from 0 to 1. And then substitute that limits, we can get the value as z squared. As we know that z value is 1 in the k direction, so we can substitute that value here. So 1 squared is 1. In the opposite side, its value is 0. So we have found all